Welcome to the CFE Media and Technology Education Session, Open Source Advantages, Integration of InfluxDB and Grafana onto an Edge Device. I'm your moderator, Mark T. Hosky, with CFE Media and Technology. In keeping with our CEP policy, please take some time to read the quality assurance slide. This session is designed for technicians and engineers who want to take a look at using open source software as a low-cost historian, where commercial options may be too expensive. Here is a list of learning objectives for today's presentation. For a seamless online experience, here are some tips. Additional resources can be viewed and downloaded on the left side of the screen below the session's agenda. If you would like to take notes within the session, click on the left panel labeled Notes to do so. This session is available on demand if you need to come back at any time. Please remember that this session will be made live at 2 p.m. Central, 3 p.m. Eastern, followed by a question and answer session after the presentation ends. An industry expert will answer viewer questions live, and those answers will be archived with the session. You can see the Q&A details in the Meetings tab on the left side of the screen. Here is some information about obtaining an approved PDH for today's session. Today's speaker is Kurt Braun, Application Engineer, IIoT Market Specialist. I'm your moderator, Mark T. Hosky, Content Manager, CFE Media and Technology. Here's a bit more about Kurt. He works with WAGO's customers to help develop solutions to meet their needs for industrial Internet of Things and for edge computing. With more than 15 years experience in controls, 10 of that with WAGO, he has a deep understanding of information technology and operational technology systems. For those taking this course, please see the Q&A details in the Meetings tab on the left side of the screen. Now we'll have a brief commercial, followed by Kurt's presentation.
WAGO offers you the freedom of adaptable industrial Internet of Things solutions to meet the needs of any application. The PFC series of controllers are compatible with common industrial field bus protocols including Modbus, Ethernet IP, CAN Open, and EtherCAT. Also connect securely to the cloud or SCADA system with protocols including MQTT, Sparkplug, or OPC UA. Leverage WAGO's new Edge controller and Edge computer for your plant floor edge of network applications. These real-time Linux-based devices can help you aggregate data, perform analytics, and predictive maintenance via Docker containers.
Hello, my name is Kurt Braun. I'm the IoT Market Specialist for WAGO North America, and welcome to today's training session. Today we'll be talking about integrating InfluxDB and Grafana on a Linux Edge device. The three topics that we'll be covering today, we'll start by looking at the history and background of the software. We'll cover the installation process using Linux and web technologies. And then finally we'll go into the configuration of the software to get it all to communicate together to create a nice dashboarding system. So with that, let's get started. Let's look at why dashboards are a compelling option before we get into too much detail. In a typical industrial controls application, you might have OEM equipment, you might be in charge of running a factory and the production associated with that, or you might be managing a building. And all these have a lot of commonalities in that they have variables and I/O points that you would want to track if you're wanting to manage the system. And so that's where a dashboard can be really useful. It gives you a really easy way to monitor different data points and visualize them, create alarms, things like that. Traditionally, we would look at deploying a SCADA system, I should say. These carry with them costly licenses in many cases. You've got to have a server to run all this software. There's usually a lot of add-ons and then all the engineering that goes into the programming of these complex SCADA systems. We're really just not after a complete SCADA. We're really only interested in logging data. It's more of historical reference for things that are happening on the plant floor and generating alarms when needed. These typically require a lot less programming. They're a little more configurable and easier for operators to analyze the data compared to complex SCADA systems that require a lot of custom training. So what is Grafana? Grafana is a web-based dashboarding system. It's very easy to learn. It's drag and drop in many cases. If you organize the data in an easy to understand way, it's very easy for your users to find the different data points that they might be interested in. Supports a lot of different data sources. We're showing how to use this with Influx today, but we can equally support a lot of different types of data sources like SQL databases or CSV files. It could be MQTT data. There's just a host of different ways to get data ingested into Grafana. You'll find that it has a very modern, visually appealing look compared to traditional SCADA systems. And it's a multi-user system, so each user can have predefined dashboards as well as customize their own dashboards for their own needs. This plugin system works really well. It allows functionality to be readily added to your system in the way of adding different graphics or adding different connectors to different data sources. And best of all, this is a free and open source software. InfluxDB is a time series database that's capable of ingesting millions of points per second. So it's very high performance, really built for IoT and analytics. It's possible to set up data retention policies that are just built into the Influx system. So after a certain period of time, the data just expires and is removed from the database. Where traditional SCADA systems require, SQL scripts to be written on a daily basis, and they have to go through and scrub the data and remove data that is considered old. And this is enterprise-grade security is built into Influx. If you look at the companies that are using Influx, a lot of big companies that I'm sure you've probably heard of. Very reliable, robust system. This is coupled with their APIs and tools, and it's all web-based, so easy to manage. It has its actually own dashboarding system, which we won't really cover in too much detail, but just know that it is a really powerful system, and it's built also on open source technologies as well. And then we'll be talking a lot about Node-RED today. And Node-RED it's a web-based GUI, so you can do all the programming in a web browser without installing any special software on your laptop. What's great about it's really easy to learn and very high performance and stable. There are over 3,000 library nodes that are in what they call the palette manager, and these add things like Modbus or dashboards, different PLC drivers, different IoT cloud drivers as well. It's very easy to customize your installation with the various software that you require to integrate. It acts as like a glue between your IT and OT, and it's really taken the market by storm. It all uses HTML5, so works with just about any browser that's on the market today. It's also cross-platform. This will work on Linux, Windows, Mac, as well as running in a container within Docker. It's really incredible how quickly Node-RED has taken the market by storm. There's over 100 million pulls from the Docker hub, and this is just Docker alone. If you considerably more than that, if you looked at native installations that are happening on the operating systems directly. I think you'll find that if you're not familiar with Node-RED, it's a pretty amazing piece of software. Just quickly reviewing the licenses of the software that we're covering today. Obviously, Linux is the Edge OS of choice. That's GPL. And Docker, the binaries are available, and there's also the source code available under Apache too. Docker is a rather large set of services that are offered, ability to do swarms and things like that, but we're really just leveraging it today to run single instance containers on an edge device. InfluxDB is covered by the open source MIT license, and Grafana and Node-RED are both also Apache 2 license. So I think it's relevant to look at the timeline of when these different softwares came out and what's happening in the edge space in terms of hardware. Going back just 6-7 years, we saw the release of the Raspberry Pi, now up to version 4. And along with that, a lot of IoT type of software, the InfluxDB, Grafana, Node-RED, being leveraged on very low energy but relatively high performance ARM-based computers. The Raspberry Pi was very popular, still is popular in the development and prototyping stage, and a lot of vendors are now coming out with industrialized ARM products that can run the same suite of software, but in a more harsh environment. So going back just 2 years is when Node-RED version 1.0 was released, and like I said, that's just had a very fast adoption in the industry, in the IoT market space. As you'll see, the capabilities that it brings to the table are quite impressive. So let's just quickly look at the flow diagram of today's training. So we start in the field. We have I/O points. These are, in this case, Modbus. They could be, your PLC that you happen to be using. And we're going to be bringing that into our Node-RED using the Modbus driver. And within Node-RED, we'll also be creating our objects and organizing the data in an easy-to-use way, so that when we create the dashboards, it's easy to find the data points that we're looking for. We're going to perform scaling on those Modbus registers, and then we're going to also insert the data into our Influx database. So Influx is really just storing the data. It's also managing the retention policies and the security layers for making the various connections between Node-RED and the client, which in this case is Grafana. Grafana is going to provide all of our visualization, any notifications that we may want to provide, as well as the multi-user nature of accessing the dashboards. Now we'll cover the installation process, and we'll start by installing Docker on our device. Docker is a service that runs on an edge device and allows you to containerize your applications. And the containers bring a lot of advantages. You can deploy containers on multiple devices, and it's easier to manage and easier to control versioning, things like that. So the first step is to use Secure Shell, which is the SSH. On Windows, you can use a program called PuTTY, and you're going to log in with the user Wago in this case, followed by an @ and then the IP address of the device. And when you do that, you're remotely connecting to the Linux command prompt on the edge device. If you type Docker and you get a command not found error, then we know we need to install Docker. It's not already installed. And that depends on the Linux version. I've got a link here that explains how to install Docker. On a Ubuntu type of operating system, we would use something called snap. So the command would be sudo snap install Docker. Some other Linuxes use something called apt-get. It would be something along the same lines of sudo apt-get install Docker. Once you have Docker installed, we can install Node-RED, assuming that we're already shelled into the device. What we're going to be doing is creating a volume, and a volume is a way for the container to share memory or storage space on the host. In this way, we can destroy the container and restart the container without losing any user data or configuration. So we'll start with the command sudo docker volume create -- name followed by the name of the container. We're going to be using node_red_user_data to store all of our Node-RED programming. Once the volume is created, then we'll issue the docker run command, and the docker run command will run with a -d, which is in daemon mode, so it'll run in the background, and then we want to give it a name. We'll call it Node-RED, and we'll associate the network with the entire host. With Docker, you can designate certain ports and minimize the security exposure. However, for the ease of this demonstration, we're just going to connect the container to the host network. And then we're going to use the -v, which connects the volume we created in the previous command with the container's data directory. And so that if anything that's saved in the container's data folder will actually be stored on the host in the Node-RED user data volume. And then the name of the container that you want to pull, which we're going to be pulling the official Node-RED container, which is Node-RED /node-red. This assumes that you have internet access, and when you run this command, it will first look to see if the image is locally on the device. In this case, it's not going to be, so it's going to go to the Docker Hub and will pull the latest version of Node-RED onto your device. The next step would be to connect to Node-RED once it's up and running using port 1800, and it would just be http:// the IP address of your device with the :1800 or 1880 for the Node-RED instance. And then you can use the palette manager to install the Modbus palette as well as the InfluxDB palette, which we'll be using in the the step 3, which is the configuration of the Node-RED. Then to install InfluxDB, it's a similar process. Again, we would shell into the device. We would create a volume, which is where we're going to store our data. We'll call that influx-storage. And then we use the same style of Docker run command. We're going to give it a different name, and we're going to attach a different volume, influx storage, to the etc. InfluxDB directory in the influx container. Then we need to do a few things with this container. When we need to shell into the container to run some commands to set up the influx tables and create a user and as well as a token. And if you don't do this step, then you have to connect with the version 2 protocol. And I think you'll find version 1 scheme is a little easier to work with in Grafana. And so it is backwards compatible. You simply have to use a command called docker exec-it, which is interactive terminal, followed by the name of the container, which is InfluxDB, bin bash. So this is like you're connecting as if you're doing SSH from one machine into the edge device. What this command lets you do is shell into the terminal of the container that's running within the edge device. And so once we are connected to the containers CLI, we can run the influx setup command that you see here, which creates a user and a password with that user, as well as a token and an organization and a bucket. And the bucket is the name of the database that you're going to be creating that we'll be storing the data into. So you can see all the commands listed below here. So we're going to do a sudo docker exec-it influxdb bin bash. Then we're going to run the influx setup command, which creates the user and the token and the org, the bucket, and sets a retention policy for 12 weeks. We're going to actually change that in one of the following steps, but we'll just initially set it for 12 weeks. There's some other useful commands like influx bucket list, which will list out all of the buckets or databases that are in the system. So that will allows you to check to make sure that it created the database that you wanted. So you can see MyDB is listed there. And then you need to run the influx v1 authorization create bucket list command to get the ID of the bucket for the MyDB. So you can see it starts with CD395. So you would just copy and paste that authentication create command, which gives the user that you created access to version 1 access into that bucket. And then we finally need to use the v1 dbrp create, which applies the retention policy to that bucket. This is probably the most complicated part of this procedure, and you may want to refer back to these slides when you're going through this. Setting up Grafana is less painful. We're going to, again, shell into the edge device. We're going to create a volume for our container called Grafana-storage. We're going to run the container in daemon mode. We're going to use the full network access. We can install plugins from the command line, or you can install plugins through the web interface as well. The MQTT panel interface here is pretty interesting. We won't have time to cover it, but it lets you put buttons to actually send commands back to Node-RED. Yeah, so then finally, if you do a sudo docker container ls, that will show you all of the containers that are running on your edge device. So at this stage, we want to have Grafana running, the InfluxDB, and the Node-RED all up and running on our edge device. Next, we'll connect to the Grafana web portal that's found at the the IP address of your device with a :3000. And from here, you can log in with user admin, password admin, and it will then prompt you to change the password, so you can change it if you'd like. And within our configuration, we need to add a data source, and you would just simply click add data source, and then it's going to have a list of all of the data sources available. Just find the InfluxDB one and click select. We need to configure our InfluxDB connection, as you can see here, and this is where we, in the previous steps where we created the Influx user and token, we will need that information to authenticate Grafana with our Influx data store. And so we're just going to basically create the HTTP header authorization, and then in the value we would put the name of the token. In my case, it's my token equals. And then at the bottom there, you probably want to change your minimal time interval to 1 second. If you leave it the default, what will happen is if you don't receive data every few milliseconds, the trending graphs will show as points instead of a line, so it won't connect the dots. So if you set it to 1 second, it gives you a little more forgiving with how quickly you're publishing data into your database. All right, well, now comes the fun part. We're going to actually configure all of this software to communicate with each other. We'll start by looking at the Modbus portion of our flow diagram. In this case, we're using a Modbus coupler, and this could be a PLC, it could be a lot of different things. But in this case, we are just trying to read the values of some I/O points. So we have a push button, which will represent a machine running. And then we have an analog input module, which has 8 channels. We're only going to be reading the first 4 channels. This particular device has an IP address of 192.168.4.23, and the port number is 502. We know that this device maps the I/O points with a certain formula, and so Modbus address 0 would be our first analog input, and then the digital points would be at in the 9th word of the Modbus register map. So just keep this in mind when we are configuring our Node-RED flow to read these registers. We just need to keep track of where these I/O points would be within the Modbus register table. Also, these analogs read in degrees Celsius times 10. So if it's 27 degrees Celsius, it will actually be reading 270 would be the value in that Modbus register. So we're going to have to divide by 10 when we get into the Node-RED portion of this. So Node-RED is a drag and drop type of programming environment, and you simply drag what you're interested in on the left hand side, and you drag it over into the right hand side where your program would reside. So in this case, we need to drag an inject node as well as a function node and a switch node. And what this will do is will allow us to configure these nodes by double clicking on them. And the inject node, we want to inject it one time as soon as the flow starts. We just need to run this one time. And the function, as you can see here, when you double click on that, you can give it a name, and then you can type in your JavaScript code there. So we're going to create an object called system, which has a running bit and a fast logging bit. And I'll explain later why we'll need those 2 parameters. And then we'll also have a thermocouple 1, 2, 3, and 4. And those will have the degrees in Celsius as well as an overtemp flag, which we can use for alarming. And then what we're going to do is we're going to assemble that into a larger object, which has system, thermocouple 1, 2, 3, and 4 of each of those objects that we created previously. And finally, we'll return that into the payload that we're going to be sending on. And then we're going to configure the change node to take that payload and move it into a global variable called machine. If you deploy this and then you monitor on the right hand side, you can view the what's called context. And if you look at the global variables, you will see the object that it created. And we need to create these variables for several reasons. First, it allows us to decouple the variables that are coming in through Modbus, and then we're also going to take those and then we're going to inject them into our database. So by creating an object, it's just a convenient place to store that data and refer back to it or use it in other parts of our program. So let's actually build this in Node-RED. I'm going to drag the inject node, the function node, and the change node, and drag wires between them. Double click on the inject node, and we'll inject this one time after the flow starts. And then if I double click on the function, we'll call this make objects. I'll paste the code in that created the objects. Click done, and then we'll go into the change node and change this to global context. We'll call this machine, and then we'll set that to the value that we get from our message.payload. We'll click done here. We'll deploy that, and now our flow is running. If I click this button and I refresh the global list, you can see the objects are shown here. So then we'll, once we've installed the Modbus palette from the palette manager within the menus on the right hand side, we would just drag the Modbus read node into our flow. And if we double click on that, we can add our device, which is going to be a Modbus slave device, and we're just going to put the IP address of that device and port 502, and we're going to read address 0 we're going to use function code 3, which is read holding registers, and we're going to read 10 words. We're only interested in the first 4 analogs, and then we're also interested in that 9th word, which is where our digital inputs are located. So if I drag a debug node from our left-hand side, and I just drag a wire between those two, then we can click deploy, and then we can monitor the register values that are coming in through the Modbus. So you can see here we're getting 19.1 degrees Celsius, 18.7 degrees Celsius, and then in our 9th register, the 8th word is a value of 1, which is our digital input, which the switch is in the true position, on position. And so there you can see a representation of the physical I/O and how that maps to our Modbus registers. So now we can drag the function node and then drag a wire between those two. And now we can type in a program for our function. We need to do the mapping from our Modbus registers into the object that we just created. So this is pretty cool. You can just type in your program right within this window. And again, this is all hosted over a web browser. You don't need to install any software on your laptop or machine that you're doing the development on. All of this software and web servers are running on the edge device, which makes it a very portable solution. So what we're first going to do is we're going to get that global object called machine, the global variable, and then it inherits all of the sub properties of it. So we're going to, now that we've brought that variable in as something called machine, we can assign the value of machine.thermocouple1.degrees C as the value that we are passing from the Modbus registers. So we're passing, in this example, 191 is in register 0. So we're going to take payload 0 and divide by 10 and move that into the thermocouple 1's degrees Celsius variable. And we would do the same for the other 4. We can also have functions here. So we know that if the thermocouple is disconnected or if there's a problem, we'll get an error bit. We can then assign the value of that overtemp to some evaluation and do some edge diagnostics on the actual analogs that are coming in. And then on line 14, we're going to create a new variable called word and assign the payload 8, which is that digital input. And then depending on if that's a 1 or a 0, we can trigger that we know that the system is running. And once you've deployed this and you're monitoring it, what you should see in the global variable list, you should see the actual values being populated in our object coming from Modbus. Again, showing how that will look in Node-RED, I'm going to drag the Modbus read, click the little pencil icon, put the IP address of the device. We're going to change this to function code 3, which is read holding registers, read address 0, 10 words. We're going to read it every second. We're going to click done. Then I'll connect that to a debug window, click deploy, and in our debug window we can actually see the registers coming in from our device. So we know our Modbus is working. We can drag a function here and we'll just put our code that we looked at to decode our Modbus registers coming in. So we're doing all of our division and we're saving it back to the global context once we're done mapping everything. Click done, connect that wire, click deploy, and now if I go back and I refresh the context, you can see there's actual numbers in the objects. So another useful thing about Node-RED is we could just program this to always inject the data at a set interval, say every 500 milliseconds or every 100 milliseconds. But in certain instances, we want to have a much faster sample rate when it's important, and then switch to a slower sample rate when it's not important. In this example, when the machine is running, we would want to have a much higher frequency of data collection versus when the machine is just sitting idle, waiting for the next production to be run on it. So that's what we're going to be doing here, is we're going to be controlling when we're injecting data into Influx. And this builds a little more intelligence into the application that oftentimes isn't available on a SCADA system even. So here we have to inject nodes, we're going to inject a 1 or a 0 to force the logging to be fast. We're also going to be monitoring that bit of that digital to know if the machine is running. But this allows us to do debugging without having to monitor or we can basically bypass the machine is running and collect data at a faster rate whenever we want. So here you can see when we drag the inject node, we just need to change that to a number and put a 0 or a 1 corresponding to which button we click. And then for the function, we're going to create, basically going to just take the payload and put that into fast logging, which is the manual fast logging parameter. And then we have to do a global set to push it back into the global list once we've edited that fast logging bit. And you can also use a node.status to create a visual indication right below the node when it's running to show what the current state is, which is also helpful when you're debugging. Here we can add a reset. So if you force it into the fast logging, and let's say you forget and you go home for the day, after 4 hours it's going to go revert back to the slow logging. And so we can use this cron node, and you can cron is a service that runs within Linux, and basically we can dictate when we want this to trigger. We're going to trigger it every 4 hours, and it's going to just reset that fast logging back to 0 when that triggers. This next section is we're also going to use another cron object, and that will be our trigger for the slow, when we're in slow logging mode, and then we'll also have a faster logging. So this will trigger every second, and then the slower one will trigger every hour. And then the code for we're going to use what's called a topic. So every wire that you connect between the nodes has a payload, which is just a JSON object. It also has a field called topic, so message.topic. And if you put something in there, you can then use it to filter in subsequent flows to determine where that message came from. So in this case, our inject speed will be looking at those 2 bits, whether system.running, which is our digital input, or, which is represented by the 2 vertical lines in the if statement on line 2, system.fast logging. So either one of those are true conditions, then we know we want to trigger on the faster topic, which is shown as second. And then if the message topic is hour, then would be the other condition. The next step is to feed that into another function, which is going to grab the system object from the global variable called machine. So machine.system. And we just need to create a variable that's an array and populate the first array element with that object. And then we're going to return that to message.payload, which then gets fed to our InfluxDB node. You have to configure the server for the InfluxDB out, and just click on the little pencil, and here you can put in the token that we created, as well as the organization bucket and the measurement that you want to call this. So we're going to call this system just to match what we have in our flows. And then would we repeat this for the other objects in our global context, which would be our thermocouples. And we simply need to create a variable with the name that we want to call that. So in this case, thermocouple 1, then pass that into an array, element 0, return it as the message.payload, and then update the DB out node with the name of the measurement that we're passing to it. So we would have one for number 1, number 2, number 3, and number 4, as you can see here. So what we'll do is we'll rename this flow. We'll call this Modbus mapping, and then we'll create a new flow, and here's where we'll put our InfluxDB portion of the program. So what I'm going to do is I'm going to drag the inject node. We're going to inject a number, 0. We'll copy that, paste it using Control-C, Control-V. We'll make that a 1, and then we'll put the function here. This is for our fast logging, and this is like I said, a way to force the data to log at a faster rate. So we're just going to connect those together and click deploy. Now if I click the 1 and I refresh, you can see the fast logging is a 1. If I click to 0, I can set it back to 0. Now we're going to put in our cron. So I'm just going to search for cron. There's cron plus, and then we'll connect that to a function. This is to reset our fast logging back to 0 after 4 hours. So I just need to change the cron job to every 4 hours, and we'll call this every 4 hours as the name. And if I go into the function, here I can paste the code in to set fast logging back to 0. Click deploy, and we would have to wait 4 hours to see if this works, but I have tested it and it does work. So now we're going to add another cron job, as well as an inject node and a function, actually 2 functions. Just connect them up as shown here. This cron job is every hour. This is our slow logging trigger, and then we'll go into our inject and we'll set that to an interval of 1 second, and we'll just call that every second. And now I can go into my function, and we need to set the topic to every hour. And then on our function, we're going to have some if statements in here, just basically to determine whether we're needed to log data every hour or every second. So I'm just going to paste that code in here, and we'll call this inject speed. Once we've deployed that, we can see that everything's updating correctly in the node statuses, and now we can actually perform our injection. So we just need to drop a function along with a DB out, connect those up. Then we need to go into our InfluxDB node and configure that with the proper token and update the bucket accordingly, as well as the organization and the measurement name that we want to call it. Now that we've done that, we can kind of move things around. We can click deploy and just verify that everything is working. We can go in, copy and paste, and configure the thermocouples 1, 2, 3, and 4. And at that point, we're ready to proceed to the next section. The next step is to configure our InfluxDB. So Influx has its own web-based management. We can access it with port 38, and we can log in with those credentials that we created in the previous step, which was we used Wago in that example, and then the name of the bucket that you created. So let's think a little bit about storage space, especially on an edge device. We're usually somewhat restrained in how much data we can log, and so we don't want a situation where we run out of storage space on our edge device, and that's where Influx really does a great job. So we can, the new data comes into our database, and then we can set how many days before we consider that data old data, and then we just remove it and we purge it. We can configure this very easily within this web-based management. We can click on the bucket we want to edit, and we can set the data to expire after a certain number of days, hours, weeks. In this case, I'm going to set it to 90 days. And then if we click on Explore, all of those objects that we're publishing, we can navigate into our bucket and select those objects, and then filter by the actual variable that we're interested in, and it instantly shows you the value that's in the table for that parameter. You can also do aggregation, where you can look at, you can do averaging. You can do a lot of math analysis on these data points, all from within the Data Explorer. But now that we know that the data is being logged, we can then move on to our Grafana configuration. So looking at this in real time, I can connect to the web-based management with the credentials we talked about, and I'm going to connect to my DB bucket. Click Continue. Then I can go into Quick Start, and under Data, there will be a Buckets tab that allows me to change the settings of my bucket, and here I can change my retention policy to whatever I want to change it to. I'm going to set it to 90 days. So again, we're going to connect at the IP address of our edge device with :3000, and from there we're going to log in, and then if you click on Create Dashboard on the left hand side, we'll be greeted with this screen, and we're just going to click Add New Panel. Then on the right hand side, you can configure which kind of visualization that you want to create. So we're going to start with a graph, and then towards the bottom of this screen you can select the which table you want to pull from, and then you can select which object. So we're going to choose thermocouple 1, and then for the field, we'll choose the degree C. You immediately should see that parameter displayed, and you can select, you can click the plus query button. You can add more pens to your graph. So we're just going to repeat that process. We're going to add 3 more pens, and we're going to select all 4 thermocouples. So if we look at this in real time, here I'm clicking add new panel. I'm going to select the graph. I'm going to call this thermocouple 1. I'm going to select my data source. It's thermocouple 1, degree C. Click the plus query button, and now I'm just adding the other 3 thermocouples to my trend graph. Once that's done, I can click apply, and now I can view it on my dashboard. You can click apply, and then you can click the add new panel button. And with this panel, we're going to change the visualization type to a gauge. And in a similar way, we're going to select the thermocouple 1's degree C field. And now it will be displayed, a gauge to show us the current value of that field that's coming in. You can resize these panels very easily just by dragging the lower right hand corner and create the look that you're after. And then we can duplicate. If you click on the little drop down for that panel, and we can then just edit the duplicated one, and we can just change the thermocouple to thermocouple 2, and then just repeat that for the 3rd and the 4th thermocouples. So let's go through that process in real time. Click add panel, select the graph. We'll call this thermocouple 1, and then we'll select our object, and then we'll filter it by the degree C, and we'll just resize that, and we'll duplicate it, and we'll modify and edit it for thermocouples 2 and 3. And here's where it's really important that you can group our data in objects. It lets you organize your data in a meaningful way versus just a big flat list of variables. It can be unmanageable. So you can see really how powerful this system is given all of the features here. We're going to add another graph here. We're going to change that to the running field so we can monitor the status of our digital input. And then you can click the save button, and you can give it a name, and that way you can retrieve this dashboard at a later date. You can also change the period of data that you want to go back and look at by using the drop downs, and you can also change whether the graph automatically updates. So you can set it for like a 5-second update, and then it'll, even though it's maybe logging data every half a second, it will only update the screen every 5 seconds just to reduce the overhead. Usually you don't need to actually see the data coming in more, at a more frequent rate than every 5 seconds. So here you can see when we click the save button, we're greeted with a little pop-up where we can give the name that we want to call it. And that's how you would retrieve it from our home screen. You'll see a list of all of your dashboards, and you can change the default behavior, but normally this is when you install Grafana, that's how it's going to operate. Here you can see, we added the code to control the rate in which we're logging the data. So we're going to log it every hour when the machine is stopped, or every second when the machine is running. And so on the right hand side you can see the running bit, and at 9 o'clock, which is in the on the hour, that cron job triggered, so we logged the data, but the machine was stopped at that point. And so that's maybe a useful thing if the machine is stopped for a period of several days. It's a very little amount of data being stored, but it may be useful to know things like temperature or pressures. Even though the machine's not running, there are things that can happen when the machine is offline, for example. So this just gives you a little more control over your data and how you're keeping track of it. Now that we have our dashboard built, let's take a look at how easy it is to operate it. You have a nice drop down where you can select the time range you want to look at. Let's take a look at the last hour here. And I can set this to auto refresh every 5 seconds. I can save a copy of the dashboard. So if I make a few changes and I want to modify it and have both copies, I can do that very easily. If I want to zoom in on a particular point of data, I can just drag and it will automatically refresh all of the graphs and gauges for that time period that I'm selecting. As you can see, the usability is really great, and you can see why it's such a compelling solution. So I think this hopefully was a useful example of how you can leverage open source software in a edge device to create a useful dashboarding system and monitoring all kinds of PLC variables very easily, and empower your users to create new ways to look at data that they maybe haven't looked at before. Thank you.
Now it's time for the question and answer portion. Please submit your questions using the Zoom question and answer interface.